Welcome you all to the last week tutorial of multivariable calculus. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am pursuing my PhD in the broad area of fractal geometry and dynamical systems. I am the tutorial assistant of this course. In this particular tutorial, we will do some illustrations that are based on Green's theorem, surface integral, surface area, divergence theorem of Gauss, and Stokes theorem. Okay. So let me write the first one. Verify the Gauss divergence theorem for f 4x I cap minus 2y square j cap plus z square k cap, and S is the surface bounding the region x square plus y square equal to 4, comma z equal to 0, and z equal to 3. So we have given a vector field, and we have told about the surface which is bounding this particular region. We have to verify the Gauss divergence theorem. Try this one. Uh, Mr. Arya, sorry, I'm not sure about this. You can ask that particular in that particular Q&A post group. You can ask from the NPTEL itself. Hmm. So you try this one. Till then, I'm writing the statement of Gauss divergence theorem. Anybody has any idea that how can we follow up this question? Anyone? Rekha? So, what is Gauss divergence theorem? Anyone? Okay, let me write a formal definition. Let D be a closed and bounded region in the 3D space whose boundary is a piecewise smooth surface S. That is minted in the outward direction. Further, let so we have given they be a closed and bounded region in 3D and whose boundary is a piecewise smooth surface S that is oriented in the outward direction. Next, we have given a vector field that is Vxyz, V1xyz I cap plus V2xyz j cap k cap. Be a vector field for which V1, V2 and V3 are continuous and have continuous first order partial derivatives in some domain containing particularly D. Then we can say that this double integral f dot n cap ds is equal to triple integral over d divergence of f dv. And here again n cap is nothing but the outward normal vector to S. So this is the statement of Gauss divergence theorem, and S is the surface integral. So we need to check first of all either these conditions are fulfilled in the given domain, like D is a closed and bounded region in 3D space, and the curve is piecewise smooth, and we have to take the direction is outward normal direction. Okay, so the given cylinder or surface is the cylinder x square plus y square equal to 4, which is varying from z0 to 3. So roughly I'm just drawing an image of cylinder x, y, z, and we have given that this is 2, just a second please. So we have given the surface. What was the surface? X square plus y square equal to 4, comma z is equal to 3, and z is equal to 0, and z is equal to 3. So that is z is equal to 0 means xy plane, and you can say this will be z equal to 3 particularly. This is our given cylinder. Clearly we can see that this cylinder is closed and bounded region, and moreover this surface is particularly, this is S1, this is S2, that curved one, and this is S3. All of these threes are piecewise smooth. Now we can apply our the other thing is that this vector field have continuous and continuous partial order derivative. Clearly you can see this is the polar contains the polynomials 4x, 2y square, and z square, and these are continuous functions on any domain on r square, you can say, or r cube, and also it has a continuous partial order derivative. So all the conditions of this particular Gauss divergence theorem has been fulfilled. Now we just need to apply, first of all we have to calculate this surface integral, and the other thing is that we have to calculate this divergence. Here I have mentioned v in the above, so I should take v here also rather than mentioning. So this here, this dv is nothing but dx dy dz, or order can be changed, dy dx dz. So we have drawn our surface. Let me correct it. Okay. So we have to calculate LHS side and RHS side, and we have to prove that this both LHS and RHS of this equation number star is equal. So our given vector field is this. So it is easy to calculate first of all the right hand side. So what we will do, we will first calculate its divergence. Divergence of f is del over del x of 4x del over del y of minus 2y square del over del z of z square. What it will give? 4 minus 4y plus 2z. Am I correct? If anybody has any doubt, yes,
Yes, sir.
you want to say something, or you are agreeing with
No,
me
sir,
here?
correct.
Okay, okay, thank you. So now we know that what is the divergence. The next task is to calculate this right hand side, and right hand side was we are calculating over this d and divergence of f and dv. So if you will look into this, this is nothing but a circle of radius 2 and centered at 0, 0. So can I change directly into the polar coordinate if everybody has agreed to this? Okay, I am changing from 0 to 2 and 0 to 2 pi. This is our r and this is our theta, and our z will vary from 0 to 3. So this will be 4 minus. And what is y in polar terms? R
R sin theta.
sine theta. Good. Plus 2z. And dz and dx dy will change into r
dr.
d g theta. Now calculate this quantity first.
Excuse me, sir.
Yes, please.
Why do we integrate with respect to z first?
You can even take is after that dz on. It's a constant limit, so it does not matter if you will integrate it first or if you will integrate it second or third. But we are working as polar coordinates, so you can say that we have to like just put it dr d theta. We are taking radial component, na? So dz can be replaced even first also, even in the last also. It does not affect the answer.
Okay.
So anyone got any answer? Oh, let me also integrate parallelly 0 to 2 pi, 0 to 2. So this will be 4 minus 4 sine theta times r will be outside times z plus z square 0 to 3 dr d theta. So this will give us 0 to 2 pi, 0 to 2, 12 r minus 4 3s are 12 r square sine theta plus 9 dr d theta. I hope it is correct till now. So the next one is to integrate with respect to r 0 to 2 pi. This will give us 6 r square minus r cube by 3. This will be 4 times r cube sine theta plus 9 times r, and this will go from 0 to 2 d theta. So this will give us 2 to the 24 minus 8 4 the 2 plus 18 d theta, and 24 plus 18 is 42 minus 32 sine theta d theta. Okay, now this will be 42 theta minus, or you can say now it will be plus cos theta from 0 to 2 pi. Cos 2 pi and cos 0 are equal, so we can directly say it will be 84 pi. Okay, so you got the right hand side as 84 pi. Now what about the left hand side? And what is the left hand side? That is the surface integral. You need to calculate the surface integral. So Let us discuss about the surface also. Then we can say our theorem will be verified. So in order to discuss the surface, we have given this x square plus y square equal to 4. And what is our n cap? N cap is some gradient of f divided by its magnitude. It is unit normal vector. And here f will be, f we can see it as x square plus y square minus 4 equal to 0, like this. Okay, so gradient of f will be 2x I cap plus 2y j cap, and its magnitude will be under root 2x square plus 2y square, which will give us 2 times of under root x square plus y square, which will be equal to 4. So n cap will give us x I cap plus y j cap divided by 2. And we know that from our LHS what we need. We have to calculate this surface integral over surface f dot n cap into this ds. And ds can be expanded as either dx dy divided by n cap dot k cap, or ds can be expanded as dy dz divided by n cap dot I j cap. Here it would be I cap, because in the above we have taken, in the numerator we have taken dy dz, and dx dy dx dz divided by n cap dot j cap. We can take either of the three possibilities, but here n cap dot k cap in our particular question is 0. So we need to avoid this one. Now we can consider any of these two. Suppose I am working with ds is equal to dy dz n cap dot I cap. Okay, so this will give us dy dz divided by x by 2. And since we are working with y and z, so x must be transformed to dy dz divided by under root 4 minus y square. Okay, because we have given that x square plus y square is 4, and we will take the range of x and y accordingly. Now what is LHS? Double integral f dot n cap ds. Now we know the value of f, we know the value of n cap, we need to calculate f dot n cap. So here was our f. So let me write it from this one. So f dot n cap will be f dot n cap yes please.
So there are three surfaces.
Muthukumarji, let me tell the things in my way. Then you can argue on that if I miss something. Okay, please give me my time. F dot n cap. Our given f is 4x I cap minus 2y square j cap z square k cap dot, and given n cap is xi plus yj divided by 2, xi cap plus yj cap divided by 2. See, this particular tutorial is contains a lot of calculation, so kindly just participate in it. If you have not done earlier, then you can try to learn it from here. And since it's our last tutorial, then this just be please interactive, a little more interactive. It will be good for you. So this will give us 2x square minus what will it will give y cube. Is it correct? Okay. So let us put it here all the values over s 2x square minus y cube, and we know that our value of this is dy dz divided by x by 2, so it we have changed it at 2 by x. Let us put it like this, 2 by x. Now what we know that our circle is x square plus y square equal to 4, and the other thing is we know that z is 0 and z is 3. So how you can put the limits? We can put the limits like this. We can move z from 0 to 3, and what is the parametric form of this particular? X is equal to 2 cos t and y is equal to 2 sin t, and where t varies from 0 to 2 pi. So this will give us 8 cos square t minus 8 sin cube t into, this will give us dy. Dy will give us 2 times of cos t, that is 4 times of cos t dt dz, and x is 2 times of cos t. So 1 cos t will cancel out, 1 2 will cancel out, it will give us 0 to 2 pi. So since we are integrating t first, so we should put the limit of this t first. So let me rewrite it as z 0 to 3 and t 0 to 2 pi. So this will be 0 to 3 and cos square t 0 to 2 pi. Cos square t can be written as, how can we write cos square t? 1 plus,
Cos 2t by 2.
good, 1 plus cos 2t by 2, and this sine cube t can be written as,
Sin 3t formula. 3 sin t minus 4 sin cube t.
so it will be 3 sin t minus sine 3t divided by
4.
4, right? So this will be dt and dz, and we have already arranged all the constant as 16. So integrate this one. So this will give us t plus sine 2t divided by 2 and whole divided by again 2 minus 3 with negative sign. So I am rewriting it as cos 3t divided by 3, and with negative sign minus 3 cos t whole divided by 4, and this will be 0 to 2 pi and dz. So since sin t, cos t and 3 cos t, all of them has values same at 0 and 2 pi. So we can just deal with this expression t, and this t will give us 2 pi and divide by 2. This will give us 16 pi, and we are left with 0 to 3 dz. This will give us 3, and this is 48 pi. Okay, so our LHS was 84 pi, and our RHS was 84 pi and LHS is 48 pi. So obviously this is not equal to RHS. So what that means, we have missed something. So can anybody tell me what we have missed? Why we are having different answers?
Sir, bottom surface and the top surface will be added, sir.
Good.
S1 and S3.
Yes. So this is because it has been given that 3D space whose boundary piecewise smooth surface S. So we have to consider all of the surfaces. So here we have just calculated this particular integral
Curved
with
surface.
curved surface, right? So with respect to S2. So if I will write for curved surface S2. See, if I want, then I can let you know directly by S1, S2, S3. But I have made to you realize that we got some different answer. That means there might be some different surface. So that is my way of letting you the things. So that is why since we are working on S2, so we will all at each place we will replace it with S2. So it is a general formula. Here it will be DS2. Again, it is DS2. And since it is not the whole soul LHS, so what we can say, this is the particular value of the integral over S2 rather than writing it at LHS. So we have integrated over this S2 and then we got the value 48 pi. Now the left surface is this particular S1 and this one is S3. Now tell me, if I want to take a outward normal vector, what will be the outward normal vector with respect to this S1? Let me write. Yes, someone is trying
K
to
bar, sir. For
K bar or minus K
S3,
bar.
K bar
See,
along z axis.
okay, let me mention here for S1. S1 is x
For
square
S1, negative K bar.
and z is 0. Now tell me. That means, so this is our cylinder that I have roughly drawn again. So this is our S1 particularly, z equal to 0. So we want that outward normal vector. If I will consider that k bar, so the k bar will be in this direction. Can it be possible?
No, sir. Outside drawn
Outside.
unit normal.
So we need
But here, sir.
our unit normal vector to be outward.
Outward.
Therefore, this will be in this direction, that is opposite to the k cap. That means it is clear our n cap is nothing but minus k cap.
K cap.
So our f dot n cap only left with the component in the direction of z. And what is in the direction of z? It is z square. But observe here, over this surface, this z will be, this z is 0. So this will be 0. If our this f dot n cap is 0, so over this s1 f dot n cap ds1 will be 0. Understood? Now let us come to this particular s3. Let me write explicitly in the same way that we wrote for s1. What is s3? So this will be, yes, s3 will be z is equal to this 3. Now what will be the outward normal vector for this s3?
K cap.
K cap. Since it is our s3, this one, so this will be outward normal vector. So n cap is k cap. Now again we need to calculate f dot n cap. Just we need to focus in the kth component and this will give us z square. And since z is 3 over this surface, so this will give us 9. Now what is we left with? ds. So ds is, as I told you, it can be dx dy, and since n cap is equal to k cap, so we can easily say that n cap dot k cap dx dy, and k cap dot k cap will be 1. So this will be dx dy. So our this over S1, this surface integral f dot n cap, this ds1 will change to over this S1 9 times dx dy, and this will be nothing but 9 times S1 dx dy. What this quantity represents? Either one way is to calculate that harder way, that you would calculate over this surface x square plus y square equal to 4. This is our S1.
Circle area, sir.
Good. So smarter way is area of S1, or S1 is circle of radius 2.
2 units.
So this will give us 9 pi 2 square. So this will be 36 pi. Now we have covered all the three surfaces. Now we can say that we can guarantee that LHS is equal to F dot n cap ds over whole S, which is the flux over S1 plus the flux over this S2 plus this flux over S3. So over S1 we have seen it is 0, right? Over S1 this is 0, and over S2 we have calculated it is 36 pi. Over S2 is a curved one, so it will be 48 pi plus 36 pi. Add them, you will get 84 pi, and this 84 pi is nothing but triple integral of divergence of f dv, which is equal to our right hand side of star. So Gauss divergence theorem has been verified. What you have learned from this particular
Question,
question?
sir.
Yes, please.
Sir, sir, ds is quietly depends upon the orthogonal projection of the surfaces, sir.
Yes.
That means suppose S3, we are taking orthogonal projection, which is taken on xy plane.
Hmm.
So that we are taking ds is dx dy upon n bar dot k bar. In my
Yes.
knowledge, sir, is it
Yes.
correct or?
Yes. Yes. It is correct.
Okay, sir. Thank you, sir.
Yes. So from this question we have. Yes,
Excuse
please.
me,
Yes. Yes. Please.
I want to just to see that integral over the surface S2.
S2. Okay. Here is the. You just need to see the calculation or the from the above. S2 we have started from there.
No, no,
This is
that integration part.
okay.
We
This
have
is this is
dy
integration.
dz, right?
Yes.
Dy dz.
Yes. Dy dz.
Okay, that dy dz we have calculated as
This
dt.
parametric form. Yes. Parametric form.
What is the parametric form where it has come from the equation x squared plus y squared equal to 4?
Yes, you are right. X square plus y square equal to 4.
Sir, those are cylindrical polar coordinates, sir. X is r cos theta, y is r sin theta, z is
But
z.
here R is fixed. That's why I'm saying it's parametric form.
Yes, sir. Taking
Okay.
2.
Yes. Any other doubt, or shall I complete this statement of this conclusion of this question number one? Okay. So what we have learned that we need to always focus on the exact given statement of the theorem. In the theorem, it has been told us that we might have a piecewise smooth surface S, and this D be the closed and bounded region. So what we have missed in the first calculating the first time flux or surface integral, we have missed two surfaces. So it is always necessary to cover all the surfaces. Then only the Gauss divergence theorem will be verified. Okay. So next is I want to shed the light on this Stokes theorem. In the same way, we will verify the Stokes theorem. Second one is verify Stokes theorem for f is given as 2x minus y I cap plus, or you can say minus y z square j cap minus y square z k cap, and C is circle, the circle x square plus y square equal to 1 corresponding to the surface of sphere of radius 1, or you can say unit radius. So we have given our force, and we have also given that C is the circle, x square plus y square equal to 1 corresponding to the surface of sphere of radius 1. So we want to verify this for this particular F force and this Stokes theorem. So for that, you try this one, and let me write this exact statement of the Stokes theorem, what it states. You may try that also by your own. Stokes theorem. So it states that let S be a piecewise smooth orientable surface bounded by piecewise smooth simple closed curve C. Now we have given a vector field Vxyz as V1xy, or let me get from there also, that we are assuming the same notation for vector field in the same condition. That is why I'm taking from here. So what we can do, we can put it here, that we have this vector field where v1, v2, v3 are continuous and have continuous first order partial derivatives. Now the next one is, if if observe here, if C is traversed in the positive direction, then our integral v dot dr over this C will be equal to our surface curl of this v dot n cap dA, and this again, this n cap is where n cap is outward unit normal vector, and S is our outward unit normal vector to S in the direction of orientation of C. So this is our statement of this particular Stokes theorem. So this here, this rather than this D, we have to write it as, since we are using the notation S. So we have given S be a piecewise smooth orientable surface bounded by a piecewise smooth simple closed curve C, and we have given a vector field, and we are taking the condition that these all these components of this vector field are continuous and have a first order partial derivatives in the some domain containing S. If C is traverse in positive direction, can anybody let me know what is the positive direction?
Anti-clockwise direction.
Anti-clockwise, or you can say counterclockwise. Then we can say that this line integral is equal to the surface integral. So we need to particularly verify this quantity. So let us consider this force field. This is our force field. Now, and what is our surface? Surface is x square plus y square equal to 1. So, any guesses on which part is easy to calculate? I mean, that left hand side part or right hand side part? Which part is easy to calculate?
Right hand side, sir.
Right hand side. Okay. So, I am assuming you are saying correctly. So, let us calculate right hand side part. First of all, we need, again, we need del cross f here, and n cap and dA. We need to calculate these things. So calculate it is its curl. Now this time you will calculate the curl and you will let me know. 2x minus y z square minus y square z. What will be its curl? Tell me. What will be its curl? Easy, you can do it.
K bar, sir. K cap.
So this will give us only k cap. Now what will be n cap? So for that, let us first write the expression. This RHS is surface integral over this del cross f dot n cap ds. Now let us do some smart work in the way here. K cap, we know that, and this is n cap. Now you know that if you will take the projection over xy, so this will be nothing but n cap dot k cap. Can these quantity may differ or they are commutative with dot product? They are commutative with dot product, so you can say that this is a scalar number, or you can say, so you can cancel it out. Again, this s dx dy, what is this? This is the area of,
Circle.
yes please, area of circle with unit radius. I think we have taken that unit radius circle. Yes. So this will give us pi
Pi.
1 square, that is pi. Now what is left with? To check left hand side, and left hand side is integral f dot dr. So what is our C? C is our x square plus y square equal to 1. Now tell me uh, what we have to use to calculate this line integral. I mean, can we use polar form or we have to use parametric form? Abdul, you will let me know.
Parametric forms.
Good one. Now you understand why I have told their parametric form, because we have to just need one variable. Okay, so here you have given that x square plus y square equal to 1, and so parametric form will be rt is equal to cos t I cap sin t j cap and 0 k cap. If it is x square plus y square equal to 4, so here it will be 2 cos t plus 2 sin t. So since z is 0, so you can smartly observe that this factor and this factor will going to be 0. We will left with only this 2 times of cos t minus sin t into dx. So and t will varies from 0 to 2 pi, 0 to 2 pi. So this will be 2 times of cos t minus sin t, and what is dx? D of cos t, yani, excuse me, minus sin t dt. So what this will give you? 0 to 2 pi. This will be minus sin 2t, and with the positive sign, sin square t. Sin square t can be written as 1 minus cos 2t divided by 2. Integrate this and tell me what is the answer. Integrate this one. Yes.
Obviously, pi, sir. Answer.
Nah, obviously, no, we are verifying. So
Yes,
we
sir.
cannot say that obviously. So if it is that much obvious, then there will not be any mistake like cause divergence theorem. So there might be something. So we need to learn how to calculate that line integral, and as well as parallelly this surface integral. Main thing is surface integral is difficult a little if you will not go with the basics. So it will be sine 2t divided by 4, 0 to 2 pi.
Sir, pi, sir.
So it will be pi. And what was our pi value? It was for S del cross F dot n cap ds, and which is RH. So again, here also we can say that Stokes theorem has been verified. Now I am giving you one more question related to this Stokes theorem. Now you will verify this. Verify Stokes theorem for the given vector field F as 2y I cap minus x times j cap plus 3y k cap, and C is the cylinder, x square plus y square equal to 9, comma z equal to x plus 3, oriented in the counter clockwise direction. What is counterclockwise direction? It is positive direction. So we have given a vector field and we have given our C, and which is consisting of x plus y square equal to 9, and the equation of a plane z is equal to x plus 3, and we need to verify the Stokes theorem for this particular given vector field and this curve C, or you can say cylinder C. So try this one. Yes, please.
Where the surface is open.
How can you say that the surface is open? How
So
can you?
to verify Stokes theorem,
Yes.
the
Like,
surface must
that I
be
know.
open.
So what is the problem in this particular? I'm asking that.
Without knowing where it is open, how can we find out the curve C?
So whether I have told you that it is closed from the down, or you can say XY plane. Suppose if I will roughly draw this one, X, Y, and Z. Okay. So this X square plus Y square, this will give you a circle in XY plane of radius 3. And the other one is this Z is equal to X plus 3. So I am just roughly drawing it. So it is some kind of a plane, and from this here cylinder is going on. So from this side you can say this is open from this XY region. Okay, that is why we can apply Stokes theorem here. Now try this one. So this is a really rough diagram, so don't rely on that. So we know that we need to calculate the surface integral and we need to calculate f dot dr. For surface integral, we need to calculate its curl first. Anyone has calculated its curl?
3i cap minus 0j cap minus 3k cap.
Let me verify it. Yes, you're right. So I'm not writing it. 3i cap minus 0j cap minus 3k cap, right?
Yes, sir.
So n cap will be, since we have
xi
given,
cap plus yj cap whole upon 3.
see here,
Del so
listen,
del
listen,
f by
listen, 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 listen.
modulus of del f. Yes.
Let me complete it. So observe from the statement, the surface is open from here, x square plus y square equal to 9. Okay, so you cannot take the outward normal vector over here. We have to take the outward normal vector from this surface which is bounding above. Okay, and what is the its surface? This surface is z equal to x plus 3. So your fxyz will be, in this particular case, this will be z minus x minus 3. Okay, now n cap will be minus I cap plus a 0 j cap plus k cap and divide by its magnitude, that is under root 2. That's what I want to mention in this particular question. That's why I have choose this question. Now, what can be our ds that we will see after this f dot n cap? So let us first compute that this del cross f dot n cap. So this will give you minus 3 by under root 2 minus 3 by under root 2, which will be minus 3 under root 2. Right? Or any doubt? So we have to integrate over the surface S del cross F dot n cap ds. So since our k cap is 0, so we can easily rely on that part, or you can directly say like this: double integral minus 3 under root 2 and this ds, and this will give you ds is, we are considering dx dy divided by n cap dot k cap. So this will give you under root 2 times dx dy. This will be, if you will solve it, 3 under root 2 into under root 2 will give you minus 6 times this s dx dy. Again, this is the area of circle having the radius 3. So minus 6 pi 3 square, which will give you minus 54 pi. So this is your surface integral now. Now what we need to calculate this line integral CF dot dr, and again I am telling you what is C here. C is x square plus y square equal to 9. So you need to use parametric form, and parametric form tell you that this t will goes from 0 to 2 pi, and f dot dr and z is equal to x plus 3. So what can be the here parallelly z is equal to x plus 3. So your parametric form will give you that RT will be, if you will consider it 3 cos t I, so this will be 3 sin t j plus 3 cos t plus 3 times k, where this t varies from 0 to 2 pi. Now f dot dr will be, so what is our f? Let us take from here. Our
Sir,
f is, yes
can you
please.
please, sir, can you please r bar of t position vector? How we take, sir?
Yeah, just a second, please. Let me just,
Please explain.
yes, yes, yes. So this is our f. See here, we have given that C is our curve, which consists of this x square plus y square plus 9 and z is equal to x plus 3. So z is depending on this x. Earlier cases, what was happen in the earlier case when you are taking x square plus y square equal to 9, in that case z is constant. It is either 0 or it is either 3. Here z is depending on x. So if you will take parametric form of this is x equal to 3 cos t. So what it will correspond? What you y will correspond?
Circle polar coordinates we are taking, sir. X is 3 cos t, y is 3
You
sin
are
t.
just what you are doing, you are just compressing yourself to that circle thing. I am saying, see here, you have given an equation in xy form and you have given an equation in zx form. Okay, and how we can find out a parametric form? We first fix that one variable x, then we can find the value of y and we find the value of z. So if you will fix this 3 cos t and t varies from 0 to 2 pi, what you will get from here? It will be 3 sin t itself or something else? Tell me. Abdul?
Sir, we have completed surface integral.
Yes. Abdul, did you understand or shall I
So
explain
not,
in?
sir.
Huh?
Okay, sir. Sir, that means R cap of T is xi cap plus yj cap plus zk cap. So here z is x plus 3. So x is 3 cos t
Good.
plus 3.
So it is 3. So here from here, 3 cos t plus 3. Okay?
Okay, sir. Enough. Uh,
Yes.
So
So,
here T is totally depends upon circle limits, that is 0 to 2 pi. Not
yes.
depends upon
No.
plane.
No. Plane is just for this particular surface integral
Okay,
that
sir.
tell you that outward normal direction.
Just plane is cutting the cylinder.
Yeah, you can see that.
Okay, sir.
That circle is making and that plane is like bounding them from there. And from the lower bound, it is open. That's why we can apply the Stokes theorem. Okay.
Okay, sir. Okay, sir.
So let us put the value of y here. What is the value of y here? It is 3 sine t. That is, it would become 6 sine t. And x will become 3 cos t. And again here 3y will become 9 sine t k cap. This is our f. And what will be our dr? Minus 3 sine t I cap plus 3 cos t j cap minus 3 sine t k cap. Fine. Now multiply this. This will give you minus 18 sine square t minus 9 cos square t plus or minus 27 sine square t. Is it so? Now, what will be the smarter way? Use the identity cos square t plus sine square t equal to 1. Then you can get only one trigonometric function. So this will be minus 9 and minus 36. You will take 9 from here. 9 plus 27 will be 36 sine square t. And solving in it in a smarter way so that we can integrate over c. So this will give us 18 times 1 plus cos 2t. Am I right or
No, no, sir. 1 minus cos 2t.
okay? 1 minus, right? So it will give you 18 plus 9 will be this 27 and plus 18 cos 2t. Now what you have to do? You have to calculate this CF over this C F dot dr. T vary from 0 to 2 pi and minus 27 plus 18 cos 2t and dt minus 27t plus 9 sine 2t 0 to 2 pi minus 54 pi, and this will be double integral over s curl of f dot n cap ds. Okay, again the Stokes theorem has been verified, and what is the crux of this question is that you got confused in whether we have to take that surface outward normal vector with respect to the x square plus y square equal to 9 and x plus y or z equal to x plus 3. So it's a great learning that we have to always take the outward normal vector from that surface from it is bounded, and that open surface we will take for this line integral. Open is that one is from x square plus y square equal to 9 and where z is 0. So
Excuse me, sir.
yes, please.
In while calculating surface integral,
Yes,
I have taken into consideration that plane equation.
yes,
Plane equation has been considered.
yes, yes,
So plane surface, there is one surface. Curved
yes.
surface is another one.
So we don't need to consider that here. It is open. We need to consider that surface only in this
Now
Stokes theorem particularly.
there is a cylinder.
Yes,
A plane is cutting that cylinder.
yes,
So that plane cutting the cylinder, that is a closed surface.
yes,
And there is a curved surface of the cylinder also there,
yes,
open only at the bottom.
yes.
So that means we will have to find out surface
See,
area in around
you are
two
not
surfaces.
You are not getting that point. I am telling you with some another example.
Uh,
Then maybe you will let. Suppose in general, if I would say in rough language, this Stokes theorem is basically for specific type of figures of hemisphere. In this hemisphere, this is your counterclockwise direction curve is C. From there, it is open. Okay. And the other one is this surface. Surface is S over which we have to integrate. And this is the outward normal vector of this n cap. Okay, so we will calculate the line integral over this as cf dot dr. This is particularly for Stokes theorem, I'm telling you, and we will calculate this double integral, this curl of f dot n cap ds over this s. Okay, so we will treat this surface as only the surface, and that outward normal vector we will take with respect to this. In the same way, here our this is a plane z is equal to x plus 3, and we are taking this outward normal vector over this z is equal to x plus 3, and we are treating this x square plus y square plus 9 equal to 9 is as our curve C. Okay, that is why we are taking only that surface. In the Gauss divergence theorem, it is not the case. It is a different case in Gauss divergence theorem. We have a closed and bounded figure, closed and bounded region. That's why we will take all the surfaces. Okay. So
so
this
that
is the,
so
yeah,
we have considered the surface cut by the plane only.
yes.
So cut by the plane only.
See, again, I'm telling you, that's why we have taken that plane equation. Z is equal to x plus 3, and we have just need the outward normal vector that we have taken into the consideration. Rather than taking that curved one thing, or you can say, rather than taking this the lower one thing. The direction will be the same. That plane is cutting, the direction will be only this outward normal, nothing else. So this is just the relation with this particular Stokes theorem, you can say.
So instead of a cylinder, if it is a paraboloid, you will
Yes.
get the same answer.
What do you
Instead of
mean?
instead of cylinder,
Hmm.
if there is a paraboloid cut by a plane,
Hmm.
then you mean to say only that plane must be considered and the paraboloid surface is not at all considered.
Can you say that that paraboloid structure that you are saying, it is open in what way? Can you give me that particular example in which you can apply the Stokes theorem? I mean, paraboloid should be open and there will be a surface. Can you give me that example?
Okay, open at the top.
Open at the top
Yes.
and cutting. Where is it is cutting?
A plane is cutting a paraboloid.
Where it is cutting? Open at the top. That I understand.
Yes,
Where it
there
is
is
cutting?
the curve along which the plane cuts the paraboloid. The
Can
curve
you
along
can
which the
you give me some particular exact equation for the time being so that we can discuss it out?
z equal to x squared plus y squared. Z
Okay.
equal to x squared plus y squared is a paraboloid.
Yes. So as per your saying,
Yes.
this will
So
be
this is cut by a plane.
which plane?
The same equation we take z equal to what is the equation?
This one?
Yes.
Hmm. Now what you need to ask that
Now,
whether
now the,
the
the open is
open
open
is open is from
surface
where?
open at the top in the sense
Hmm.
the curve, the surface along which the plane cuts the paraboloid.
Hmm. So here this normal vector will be in this downward direction, or you can say particularly with respect to this space. Okay. Again, I am repeating my statement. The Stokes theorem is made for particularly these kinds of figures. Rather than taking this cylinder or paraboloid. It might obviously get confused for anyone that where to take unit normal vector or in which sense we have to take unit normal vector. That is why I have just given this example to give you the glimpse that how to again calculate or verify the Stokes theorem and how this surface is changing. Okay. So in this case also, again, we have to take the n cap in this particular direction.
No, say there are many problems. Suppose
Yes.
if you take cuboid,
Yes.
take a cuboid, open at the bottom,
Hmm.
right?
Yes.
Then are we not going to consider the surfaces or are the other four surfaces or totally five surfaces? You want to mean only one surface you have to consider? You
In
take
this,
a you take a cuboid.
see,
X is
in
equal to 0, y equal to 0, z equal to 0, x
hmm,
equal to 1, y equal to 2, z equal to 3. Take a cuboid.
hmm,
We consider we can verify Stokes theorem for a function
hmm.
for which the surface is open at the bottom.
I understood your point.
Hmm.
I'm not telling you that this is the particular limitation. As per my knowledge, I can say this that in case of this cuboid or that the other thing you can say there might be a case that this direction or you can say that curve calculation will occur, but as I'm again repeating, this is specifically for this semi-sphere type of figure rather than this making that confusing figure that cuboid open cuboid or you can say this plane cutting this particularly paraboloid. So you might maybe verify that or might let me know. Maybe I am has some limitation. I have some limitation with my knowledge. You might let me know if you have particularly from any book rather than just thinking. Okay. So now let us proceed with the next question. Question number 4. Since we have seen how to verify this divergence theorem, so I am giving you one question again related to divergence theorem. Let f is equal to z square I cap xy j cap minus y square k cap, and S is the portion of the surface of cylinder is equal to 36, and z is varies from 0 to 4 included in the first octant. Then the value of the this surface integral, let's say it is ds, then calculate this value of this surface integral for this particular question. So here let me mention you that we need to only follow this surface integral, so we should not relate this with the Gauss divergence theorem. I just want to give the glimpse of surface integral, and also here I am telling you that we are considering only that portion where this cylinder x square plus y square equal to 36 and z is lying between 0 to 4 in the first octant. So I am would specifically say that I mean the curved surface. So I need to calculate this surface integral over the curved surface. So that is why I am saying just follow the approach of directly calculating surface integral. So this radius is 6. So I'm talking about this curved one only, this curved one. So you need to calculate the surface integral for this curved surface. I'm not considering any other two surface and specifically mentioning that. Calculate this one. This might not be difficult for you. Can anybody tell me what will be n cap in this particular case?
Sir, we should take formula, sir. Del F by modulus of del F. 2xi
Yes,
cap
good,
plus
good, good.
2yj cap
N cap
by
will be here our f x y z for this curved surface will be x square plus y square minus 36, which will give us 2x I cap 2y j cap divided by 4x square plus 4y square, which will give us xi cap yj cap divided by 6. So we got our n cap. Now what is f dot this n cap? So we need to consider only this x or y direction. We don't need to consider this z k direction. So this will give us x z square divided by 6 plus xy square divided by 6. And let us do a little smart work from here, which will give us divided by 6. Why I'm saying this is a smart work? Now you can consider the dx in such form so that this x can be cancelled out. So x can be cancelled out only in the case if you will take the projection over the yz plane. So this will be n cap dot I cap. So what will be dy dz divided by, so n cap dot I cap will give us x by 6. So in rough wordings, you will say that now the surface integral f dot n cap ds will give you this surface integral x by 6 z square plus y square into dy dz divided by x by 6. So x by 6 and x by 6 will cancel out. And what is this surface will correspond left with surface integral dy dz. Now you will tell me what can be the limits for y and what can be the limit for z so that we can integrate this one. So the limit for z can be 0 to 4 and limit of y can be 0 to 6. Z square y square dy dz. Since we have taken the projection over this yz plane, we have given x square plus y square equal to 36, and yz projection over yz plane will give us x is 0. That means y square equal to 36. That means y can be plus minus 6. But we are working in first octant, so it will be
start.
from 0 to 6. And z is given from 0 to 4. So now you can calculate it 0 to 4 and y z square y cube divided by 3 0 to 6 and dz, and this will give us 0 to 4 and 6 and z square plus 6 to 36 and 2 times is 72. So dz, and after this integration you will get 2 times of z cube plus 72 z 0 to 4, and this will overall give you 416. Okay. It's like this. I hope now you are comfortable with how to calculate this particular surface integral. Okay. Now let us move to this Green's verifying this Green's theorem. So for Green's theorem, earlier question number is 4. Verify the Green's theorem for f is given as x square minus y cube I cap x plus y j cap, and C is the closed path containing x plus y equal to 0, x square plus y square is equal to 16, and y is equal to x in the first and fourth quadrant. So we have given a vector field, and they have told us that we have given a closed path containing these three curves in the first and the fourth quadrant, and we have to verify this Green's theorem over this particular region. So in rough language, if I would write, I'm not writing the for the time being the exact precise statement of this Green's theorem. I'm just telling you, assuming the all the continuity of the partial derivative and all the things, and I'm just writing this is over C m dx plus n dy. This will be integral over some s minus del m over del y dx dy over some r, you can see also. So in the rough language, I have told you what is the Green's theorem and what we have to verify, and we have given this vector field. So try this one. Just give me for 1 minute. You just try this one. So anyone is able to verify this theorem? We'll verify this one. Till then, I'm writing this formal statement of this particular theorem under some hypothesis, precisely exact hypothesis. Let's see here. Mhm. Okay. Bounding region R.
400, sir, answer.
No,
No, sir.
answer is 54 pi minus 96. If m n del m by del x or del m by del y del n by del x are continuous on R, then we can say this over C m dx and dy is nothing but del n by del x minus del n by del y dx dy. So in the given, first of all, let us draw what is our C and what is our region R. So C is bound moving from x square plus y square equal to 36 and x equal to y, x, y, and x square plus y square is equal to, it is a circle centered at origin of radius 6, and this is y equal to x, and this is y equal to minus x. And we have told that we have to consider the region in the first and the fourth quadrant. That is this is the region, and the curve C is this, moving like this. Again, I'm saying this is a counterclockwise direction that we have assumed, that we usually assume. And this is our C1 curve, this is our C2, and this is our C3 curve. So this is y equal to minus x, y equal to x, and this is x square plus y square equal to 36. So the left hand side corresponds to a curve, and this closed curve consists of three curves C1, C2, C3. So for C1, that is y equal to minus x. What will be the parametric form of for this C1? RT will be, you will tell me of this. Last time you did some mistake in confusion in this parametric form. What can be the parametric form for this y equal to minus x?
Pi minus 3j.
Yes. So again, we are starting with this t. We putting x equal to t, then we are getting y equal to minus t. You can see like that. Now we have to decide what will be the limit for t, and which is starting from this 0, 0 and going from this to this point. So this is the intersection point of this circle and this y equal to minus x. So y equal to minus x and x square plus y square equal to 36. Its intersection point will be x square 2x square. You will get equal to 36, and from here you will get 18. And what is 18? Tell me.
3 root 2.
3 root 2. Okay. 3 root 2, or we have some mistake, I think. What is the equation of this curve? 16. It was 16. That's why this is 16. So although we can verify for 36 also if we are taking from the starting 36. So 2 under root 2. So if x can be plus minus. So here, since we are considering this fourth quadrant, x will be positive. So we will reject this minus x, and y will be, since fourth quadrant, so y will be minus. So this will be the intersection point. That means t will vary with respect to this x, that is 2 under root 2. This is the limit for t. Now we need to calculate this over, rather than writing over this closed curve. First of all, we will calculate f dot dr for this particular graph. And what is our f? Our f is t if it go to 0 to 2 under root 2, and our f is x square minus y cube. What is x square? That is t square minus t cube I cap plus t minus t j cap dot. Since RT is this, so dr will be dt I cap minus dt j cap. From here you can observe that this is 0. The only weightage will given by this ith component, which will give you 0 to 2 under root 2 t square minus t cube dt, which will give you t cube by 3, 4 by 4, 0 to 2 under root 2. This will give us 2 to the 4 to the 8 to the 16 under root 2 divided by 3 minus 2 to the 4, 4 4 is 16, 16 into 4, 64 divided by 4, that is minus 16. I hope till here everybody is clear.
Yes,
Uh,
sir.
yes, okay. Which out of you, which said yes? Which shouldn't say yes? Kindly let me know, please. Abdul, you were there? Aralekha.
Sir?
You said yes or someone else say
Ah,
yes?
yes, sir. Yes, sir. Yes, sir. No problem.
So if there is no problem, please put your mic on. I want to ask something. So I want to ask here, I am doing the calculation and you are observing, I think. Still there is a mistake. Now tell me what is the mistake. I have mentioned step by step a parametric form. I have put the value in the function vector field. Still we have missed something. See here, xt is t, yt is minus t, and the given vector field is x square minus y cube. Minus t cube will be actually plus or minus. Kindly observe these things. This will increase your calculation or your effort.
minus.
So again,
Yes.
yes, please take care of these small mistakes. Now for C2 or C3 will be more easy. First of all, the line component. So this is y equal to x. And observe here that we are coming from this particular point to this. So we are just, if this is 2 under root 2 comma minus 2 under root 2, so the corresponding this point will be 2 under root 2 comma 2 under root 2. You may find out in the same way y equal to x and x equal plus y square equal to 16. So this will, for this, RT will be T I cap plus T J cap. But this T will go from 2 under root 2 to 0. This is the direction. This will go from 2 under root 2 to 0. Don't think like this is a wrong way of writing. Just it's a, we are considering the movement over of a particle over this particular curve. So this will again give us 2 under root 2 to 0, and the given force field is x square minus y cube, that is t square minus t cube, since here t and t are same, I cap plus x plus y, that means t plus t, j cap, dot product with dt I cap plus dt j cap. So this will give you t cube by 3 minus 4 by 4 plus this will be 2t, that means 2t square, 2 under root 2 to 0. So from here you will get minus 16 under root 2 by this 3, and with the positive sign this 16, and this 2 under root 2 square will correspond to 8, I think. So this will be minus 8. So this will be minus 16 under root 2 divided by 3 plus 8. So did you get any mistake, Abdul, in your solution? You told me some different answer.
No, sir, I have done only right hand side, sir. Double integral dou n by
Oh,
dou x minus dou m by dou y
so
dx dy.
that answer is has been corrected now, or it's still the same, that wrong one?
No, sir, little bit corrected, sir.
Oh, what is the new answer now?
Sir, something
Something. You are muted, Abdul, if you are saying something. So for C3 curve, the parameter form will be x equal to 4 cos t and y equal to 4 sin t. Now tell me what will be the theta, or you can say t varies from. Alika, what is the angle of this y equal to x? This angle is making.
y equal to x
It's okay, Abdul.
about x axis 45 degrees, sir.
45-degree. And similarly, this downward will be
Negative pi
minus
by
pi
4.
by 4.
Yes, sir.
Okay.
Negative pi by 4.
So we can consider this RT as this 4 cos t I cap, 4 sin t j cap, where this t varies from minus pi by 4 to plus pi by 4. Okay. Now we need to integrate this over C2 F. Here I just write it C3. This is F dot dr. This will be minus pi by 4 to plus pi by 4, and that was x square minus y cube, that is 16 cos square t minus y cube means 64 sin cube t I cap, and other one is 4x x plus y, so it will be 4 cos t I cap plus 4 sin t, this whole j cap, dot product with dr, and dr will give you sin t dt I cap plus 4 cos t j cap. This will give you minus pi by 4 to plus pi by 4. So just a little solve this. 64 cos square t sin t. Please check parallelly also. Minus minus will plus, and this will be minus sign. So this will give you 256 sin 4t plus this 4 cos t will give you 16 cos square t, and this 16 sin t cos t, and whole is dt. So after solving this a little, what will you get? Till now it is correct, I think. So you can solve it and you will get from here the answer is 50. This integration is 8 for the sake of time consumption. I'm writing it directly. You may verify 16 sine 2t or just I'm writing directly the conclusion 52 pi minus 120. Okay, so the overall closed line integral is first of all 16 under root 2 divided by 3 plus 16. The another one is minus 16 under root 2 divided by 3 plus 8, and this one is 52 pi minus 120. This will give you, so here is some mistake, it's really 54. You might verify that 54 pi, or we will verify from the RHS also, minus 16 and 8 is this will cancel out. 16 and 8 is 24, then 24 will be minus, it will be 96. So LHS we have been calculated now. Now we have to deal with this RHS, that is del n over del x minus del m over del y dx dy. So what is this del n over del x? You have calculated, I think, also. So this del n over del x is
1
coming
plus
out
3y square, sir.
good 1 plus 3y square dx dy. Now again we are working on this circular arc, so we can say that theta will go from minus pi by 4 to plus pi by 4, and r will grow from to 0 to 4.
Sir,
This will
here
be
I am taken Cartesian coordinates, sir. That is y is negative x to positive x limits 0 to 4.
hmm.
But I am not getting that answer because
Because
the
the this is breaking into two parts. That
breaking
is,
it, yes, sir. I have done only one part, sir. That's why I'm
yeah,
getting
that's why you're
wrong
getting.
answer.
I'm just mentioning it here. How? See, here it is y equal to pi by 4, sorry, theta equal to pi by 4, theta equal to minus pi by 4, this angle, and this is your circular arm. So you are just integrating till this part,
Yes, sir. Just I am
but you
done
are
negative x to
left
positive
with this
x.
part. Okay, that is why
Okay.
it is better to take this radial portion in the radial wave.
Yes, sir.
This will be 3 r square sine square theta, and this will be r dr d theta, right? So this will be minus pi by 4 to plus pi by 4, and this is r square by 2 plus 3r to the power 4 by 4 sine square theta 0 to 4 d theta. So this will give you, so this will give you 16 divided by 2, that is 8, plus 1 4 will be cancelled, 64. 64 into 3 will be I hope I am doing it correctly. Please check parallelly. So I'm just writing directly. 64 into this 3 will be 192 sine square theta d theta. So from here you will get 8 times of theta plus, I'm skipping just 2 steps. From here I will take 2 common, or you can say it will be 96, and here this will be 1 minus cos 2 theta, and the integration of 1 minus cos 2 theta is theta minus sine 2 theta divided 2, and here it will vary from 0 to 2 pi. So this will give you 16
Sir,
pi.
limits negative pi by 4 to positive pi by 4.
Sorry. Yeah, go ahead. I just made a mistake now. Good observation. So this will be 8 pi by 2 plus 96 pi by 2 minus 1 by 2. Sine pi by 2 is 1, am I right? And cos or minus sine minus pi by 2 is again minus 1, so minus minus will be plus. And 96 is also there in the whole multiplication, so it will be 96. So this will give you 4 and 4 and this divide by this 96, 48. 48 plus 4 will be 52. Pi minus 96. So that means earlier we wrote here 52. That was correct. Okay. So you just verify this one integration. I have left is just one integration. From here we are directly getting 48 plus 4, that is 52. So I hope it is clear now how to verify this Green's theorem. Now one more question is related to Green's theorem I'm giving you. This one is question number 6. Just I will not say verify, just apply the Green's theorem if it is applicable. Please observe Green's theorem will not applicable to everything, every domain. So first see that whether this is applicable or not. Let's see with the boundary of the region enclosed by y equal to x square and y equal to x, then calculate the value of the integral, and integral is given as x cos hyperbolic 2y I cap plus 2x square sin hyperbolic 2y j cap, this dot dr. So we need to calculate the value of this. First of all, draw this region and see whether you can is all the condition of this particular in the given question this by this region and by this given vector field has been satisfied or not. Then you can try to calculate the value of this integral by applying Green's theorem. I'm not telling you to just verify it, just calculate the value. Try this one. So region is like this, y equal to x square. So it is an x-based parabola. So this will be y equal to x square, and the line will be like this. Just assume that this is crossing the origin, y equal to x, and this is your region. And this will go from this direction to this direction, and this is 1 comma 1. So clearly the region is closed and bounded. And now see here, these both are continuous and has continuous first order partial derivative. So all the conditions or all the hypothesis of Green's theorem has been satisfied this in this particular problem. So we can apply the Green's theorem. So what we can say by Green's theorem, this I am just writing directly f dot dr for simplicity. over this double integral. I am not saying what will be the value of this over some region R, or what is the, I mean, limits of this. You will tell me del by del x of 2x square sine hyperbolic 2y minus del by del y of x cos hyperbolic, right here it is like congested. Yeah, it will be good. So this will be, sorry for the disturbance. So this will be minus 2 y dx dy. So this will give you 4x sine hyperbolic 2y, and this will be giving you 2x sine hyperbolic 2y. So you are left with 2x sine hyperbolic 2y dx dy. Now tell me what will be the better limits of integration with respect to x or with respect to y.
Y limits x square to x, sir. X limits 0 to 1.
Why not in the other format like dy dx? Here we are considering dy dx order of integration. So why not dx dy? You will tell me.
We can take dx dy also, sir, if we take
But
strip
what will
parallel to x-axis.
so what will be the
X
difficulty?
limits y to root
We
root
have
y,
to
sir.
see. We have to. I would just want to hear the another one mistakes that in the previous we have learned. What will happen? Like sorry, not any mistake. I mean we have to take like this.
X limits y to root y.
Y to root y. Good. And x will vary from again 0 to 1. So we can do like that also. So integrate this one to x, and this will be cos hyperbolic 2y divided by 2 x square to x dx. So this will give you 0 to 1 x cos hyperbolic 2x minus x cos hyperbolic 2x square. So what this will give you? So this will give you x sine hyperbolic 2x divided by 2 with negative sign. It becomes cos hyperbolic 2x divided by again 2, it is 4 minus, since it is 2x square and here it is x, so if I will like multiply and divide by 4, then I hope you are getting that this 2x square and derivative is here 4x. So can I say that this will be sine hyperbolic 2x square divided by 4? Is it correct? So this will be from 0 to 1. Kindly please check the calculation by yourself also. So sine hyperbolic 2 divided by 2 minus cos hyperbolic 2 divided by 4 minus sine hyperbolic 2 divided by 4. Now, now we will put 0. This will be 0. Cos hyperbolic 0 will be 1. That is, then it will be 1 by 4. And sine hyperbolic 0 is 0. You may check that. So this will give you that sine hyperbolic 2 divided by 4 minus cos.
Cancelled, sir. Sine hyperbolic terms are cancelled.
No, it is 2, it is 4. It will not
Sorry,
cancel.
sir. Sorry, sir.
It's okay. So 4 plus 1 by 4. Okay. So this will be your answer via Green's theorem of this value of that integral. Now, in the another question, I want to give you the glimpse how to calculate the surface area. That is the, I guess, the 37th lecture of this week 8. Find the area of the portion of the paraboloid z is equal to 2 minus x square minus y square that lies above the xy plane. Tell me how we can calculate this area. What is the approach? Anyone? Let's increase a little speed. Anyone?
Area formula double integral dx dy, sir.
See here, observe one thing. We have given function of three variable. That means we want to calculate that surface area kind of thing. Okay, that is depending on that. So that is if I would say more precisely, this is surface area. I'm asking to calculate the surface area with this kind of thing.
Formula, sir. 1 plus zx square plus zy square.
And this will be some dA, I would say
Dy.
dA.
Dx dy.
Dx dy you can say, and this will be the R of the region. And what will be the region here? Tell me. See, it is the intersection of this xy plane and this particular z equal to 2 minus x square minus y square. So the region will become 2 minus x square minus y square equal to 0. Xy plane means z is equal to 0. So this will give you x square plus y square is equal to under root 2 square. That means circle of the radius under root 2 and center at 0, 0. Now you need to calculate the value of zx. Zx is minus 2x and zy is minus 2y. Okay. Now under root 1 plus 1 plus 4x square plus 4y square. Now, what is the easiest way to calculate this double integral? Via this Cartesian thing or via polar?
It might be circle area. I can find.
See here
Just
it is
take out the constant.
see here it is 4x square plus 4y square. So directly we cannot calculate the circle area. We need to think about something that is a little smarter way. So precisely if I would say we can change into the polar coordinates 0 to 2 pi, 0 to under root 2, and this will be 1 plus x square plus y square is r square r dr d theta. Calculate this one. 1 plus 4r square to the power 3 by 2 divided by 3 by 2, and 4r square differentiation is 8r, so it will be 1 by 8 more d theta, and r varies from 0 to under root 2. Now this will give you the value 0 to 2 pi. You can say this 4 1 by 12 times. When you will put under root 2, this will give you 4 to the 8 plus 1 9. Under root 9 is 3, and this will be 27 minus. When you will put 0, you will get 1 d theta. This will give you 26 divided by 12. Theta will go from 0 to 2 pi, which will give you 26 into 2 pi divided by 12. So this will be cancelling out 13 pi by 6, I think. I hope all the calculation is correct in this particular question. 13 pi by, sorry, will be 3, since we are calculating, dividing with this 4. Okay. So this is the surface area for this bounded
Sir,
by this.
similar question has given in the assignment, sir. Last assignment, eighth assignment,
Okay.
fifth question. So we are getting answers as scalar, but all the options are vectors, sir, given.
Okay. Question number?
Uh, Five, sir, five.
Question number 5. Okay, let me see this one. First of all, let me write this next question, then I will see that we will do this one question. This is kind of similar to the above one, but there is a little glimpse. When you will solve this and you will understand that. Find out the surface area of the portion of the sphere x square plus y square plus z square 9 lying inside the cylinder x square plus y square is equal to 3y. So you have to calculate the surface area in a similar manner. Till then, I am seeing that question number 5 of assignment 5, right? Or assignment 7, I think. Abdul, which one? Abdul, are you there? Okay, you try this one. Till then, I'm seeing that as question number 5 of assignment 5. Abdul, as I'm able to see that you are talking about question number 5 of assignment 7. So it should be a vector quantity, no? Here we are not discussing that area. So I think either you are talking about some other problem. I think you are not here. Let me proceed with this question number 8. Why I have mentioned it again a different question that is related to this surface area kind of thing. The reason you will understand soon. So here our z is under root 9 minus x square minus y square. Since it's like over a circle over a xy plane, so I'm assuming that our surface area is we are want to calculate surface area above this. So if I would write this one, we will write it later. So zx will be 1 by 2 times of under root 9 minus x square minus y square into minus 2x, which will give us minus x by under root 9 minus x square minus y square. Similarly, zy will give us 1 by 2 times of under root minus 2y 9 minus x square minus y square. So under root 1 plus zx square zy square will corresponds to 1 plus minus y square. This will give us 3 by under root 9 minus x square minus y square. This we will get from here. Now we need to decide what will be the region over which we have to integrate so that we can decide our limit of the function. So to decide that, we have to draw x square plus y square is equal to 3y. We want to calculate surface area inside this particular region, and the other one is z is equal to x square plus y square plus z square is equal to 9. So in x on the xy plane, the projection will be x square plus y square is equal to 9. Clearly, this one is the circle with radius 3 and centered at origin, while this one is circle centered at 0 comma 3 by 2 with radius 3 by 2. If you will draw, then you will understand what can be the limit for this particular one. So this is your inside circle, which is 3 by 2 comma 0, and since it is 3 by 2 comma 0, then 3 comma 0 will be like this. Okay, so we need to calculate inside this. So obviously intersection of both of them is this particular circle, that is the inside circle, x square plus y square is equal to 3y. So my target is to convert this into the polar coordinate. So polar coordinate will corresponds to r square is equal to 3r sine theta, and r will be 3 sine theta since we are not considering the trivial case. Now the question arises, for this particular curve, if I will draw it explicitly, this one inside one, what can be the theta? It will start from 0 and then it will go from pi by 2 and it will come to again pi. Why I am saying pi and why it is not 2 pi, that is the difference between this and the earlier question, the previous question I mean. So if you will suppose you will take any value here in third quadrant or fourth quadrant for theta, so this r will become negative and radius cannot be negative. Okay, so theta must be 0 to pi. In between 0 to pi, it's covering all the values. And how to draw this one? You can obviously see from that tracing of polar curve that we have learned from one lecture. Now, what will be the surface area? Surface area is from theta will go from 0 to pi, r will go from 0 to 3 by 2. And what is the value of 3 divided by 9 minus r square r dr d theta, and this will give you 0 to pi, 3 will be outside, and this will be r square 9 minus r square differentiation will be minus 2r. So if we will consider that, this will be 9 minus r square to the power half divided by half into minus 2, 0 to 3 by 2 d theta. So this will give you 3 with negative sign for the time being, you can say, and this 3 by 2 when you will put, so this will give you 9 minus 9 by 4, and this corresponds to, I think, okay, we made one mistake here. Our r will move from this 3 sine theta rather than this 9. This will be 3 sine theta. So this will give you that 9 minus 9 sine square theta will give you cos theta, that is 3 cos theta, and while putting 0 it will give you 3 d theta. So from here you will get 9, 0 to pi, 1 minus cos theta d theta, and which will corresponds to theta minus sine theta 0 to pi, and this will give you 9 of pi. This will be your surface area lying of x square plus z square equal to 9 lying inside the cylinder x square plus y square equal to 3y. So we have learned how to verify that divergence theorem, Stokes theorem, and Green's theorem, and how to calculate the area of surface area bounded by some curve z is equal to fxy and some another curve. So
Sir, fourth question, sir. Excuse me, sir.
mhm.
Assignment fourth question, options are wrong, sir.
Assignment, see, as I mean,
Fourth,
options are
assignment
wrong.
eighth,
Abdul,
eighth
I have,
assignment, fourth question.
yes, yes, yes. Now let me complete please. Uh, Regarding the options, you have to mail or you have to message the NPTEL itself, and
Sir,
yes,
yes, sir. Already messaged it, sir.
yeah, they will definitely respond to it. Don't worry. Okay.
Okay, sir.
So
So
let
here
me
we are
just,
getting answer as scalar, sir, but vector, all options are vectors are given, sir.
I understood your concern, but the
Okay,
better
sir.
way is to reach to them, please. So let
Okay,
me
sir.
just conclude my lecture with this last question. It becomes a little long lecture, sorry for that, because it contains a lot of information. So let f, just a second, please. Let f is equal to 2x plus z to the power 3 by 2 I cap plus 3y minus e to the power z square j cap plus x cube plus y cube to the power 4 by 3 k cap, and s is the boundary of the region G below the paraboloid z is equal to 4 minus x square minus y square inside the cylinder x square plus y square equal to 1 and above the xy plane. Now calculate the value of double integral f dot n cap d sigma, and again n cap is the unit normal vector. First of all, tell me, can we apply Gauss divergence theorem here? Can we apply Gauss divergence theorem in this particular question?
Yes, sir. Uh, we can apply, sir.
How?
Because volume integral can be found, sir, here.
I have
Cylinder,
told that S is the boundary of the region G uh, below that is bounded below, I think, bound below the paraboloid and inside the cylinder this and above the xy plane. Okay, so how can you apply this? As you said, it is correct that we can apply since it is a closed and bounded curve told by Abdul, so we can apply Gauss
yes, sir,
divergence theorem.
bounded, sir. It is
Yes,
bounded,
yes,
sir.
I am saying
Cylinder,
I have not done it.
paraboloid.
Yes, an xy plane. So let me draw as per your saying a rough diagram x, y, z. It is 4 minus x square by y square. So it will be like this and it is bounded by this xy plane. Okay. And the another thing is that our surface is saying it lies inside x square plus y square equal to 1. And given over xy plane, if you will take projection of this, it will be x square plus y square equal to 4. So it will be lies inside this. Inside x square plus y square equal to 4 will be containing inside x square plus y square 1 itself. See, this is x square plus y square equal to 4 and this is x square plus y square equal to 1. So we have told that we have to calculate this integral inside this. So now we need to calculate over this particular region. Now you know that what is the value of, you know that v, your this, first of all you need to calculate the divergence.
Divergence.
Divergence. What will be the divergence of this? You can calculate directly. This will
Dou
give you
F1 by dou
2.
X.
The
2
first part will give
plus
you
3.
2 plus 3 and this will give you something
0.
0. So 2 plus 3 plus 0. This will give you 5. Now tell me if you will go with that particular that directly calculating this surface integral, will it be easy to calculate?
No, sir, very difficult, sir,
Very
because the
difficult.
cylinder.
So this is the beauty of that Gauss divergence theorem. So sometimes, many times it will decrease our calculation or decrease our efforts to get a better understanding how to calculate this flux. So this will be double integral over this S f dot n cap d sigma. Let me write by Gauss divergence theorem by Gauss divergence theorem. This will be equal to triple integral over this v of divergence of f dv. So divergence of f is it is coming out to be 5 dz dy and dx. So it will be z is going from this 0 to 4 minus x square minus y square. So I am just skipping one step. I am directly taking its cylindrical coordinates. I hope you will understand that. If not, then you can ask me. So this 4 minus x square minus y square. So x square plus y square is r
4 minus
square.
R square.
Good. Then r will move from 0 to
Radius, sir. 0 to 4.
not 4 because we are taking inside this one. This will be 1 comma 0 inside this circle. Okay.
Okay.
So this will be 0 to 1 and theta will go from 0 to 2 pi. So this will give you 0 to 2 pi, 0 to 1, and this will 5 will be outside r square by, okay, sorry, this will be r and z 0 to 4 minus r square dr d theta. So this will give you 5, 0 to 2 pi, 0 to 1, 4r minus r cube dr d theta. So from here, calculate this value This will be 2r square minus r to the power 4 by 4, 0 to 1 d theta. So this will give you 5, 2 minus 1 by 4. Did we done some n mistake? I hope no. 0 to 2 pi. So this will give you 5 into 7 by 4 into 2 pi. So 5 threes are 35 pi by 2. So I hope you got the glimpse that why Gauss divergence theorem is important in some particular case. With this, I want to end this particular last tutorial of this course, and I would like to uh, acknowledge this NPTEL team to giving me this opportunity, as well as to Professor S.K. Gupta and Professor Sanjeev Kumar to be a teaching assistants of this particular course, and students also who get very interactive to the session and to the participating in the tutorial properly. So best wishes for your exam in your future.
Thank you very much, sir. Excellent sessions, sir. All sessions.
Thank you so much.
We are very grateful, sir.
See,
Thank you so much.
I just would like to mention one thing in the end. It might be happen at some point of time that there might be some mistake from my end also. So it's a process of learning for a teacher and for a student also. So I hope
No, sir,
you
you are teaching excellent, sir. No
no,
problem
no,
at all,
it
sir.
happens sometimes. So maybe just
No, sir.
for example, like today's or maybe some in this discussion, it happens. So I'm just saying it's a process of learning. Kindly ignore my mistakes if I have done something. Being a teacher, you are always a learner. So it's open for learning always. So I hope this will be a good session for your tutorials. Best wishes for your future. Okay, thank you.
Sir. Thank you, sir.